Let's move on to talk about some function guarantees that we have in Elm. So one guarantee that we have is every Elm function, if you give it the same arguments, you're going to get the same return value, no matter what. Same arguments, same return value, no exceptions. So here's an example of a function in JavaScript that does not have that characteristic. If you call math.random with the same arguments, which is to say no arguments, you expect to get back not the same result. In fact, if you did get back the same result, math.random would be very boring and not useful. It's a very important property of that function that it gives you back different results every time you call it, or at least most of the time you call it. However, because Elm has this guarantee, this cannot possibly be the API for Elm's randomness. This just wouldn't work because it doesn't fit with Elm's guarantee. So instead we have something called random.generate, which works a little bit differently. So to illustrate sort of how random.generate works and how it's different from math.random, let's say that we're going to implement a feature. So you know how like in chat apps, a lot of the time you'll start up the chat app and the first thing it'll do is it'll show you a randomly chosen greeting like, hey, how's it going? Or today's a nice day, or you should get outside more, something like that. So let's say we wanted to pick one of those at random to display to the user. Well, just by the type of this function here, pick greeting, list string to string, I can tell you that this is not going to give me a different greeting every time I call it. In fact, I can be quite sure that if I give it the same list of greetings, it's going to choose the same one every single time. Because again, if you call an Elm function passing the same arguments, you have to get the same result every time. That's a rule of the language. So if I call it passing the same fixed list of greetings, well, every user is going to see that same greeting every single time. It's unavoidable. That's just a design characteristic. So that sort of can't be how we're going to do this. Okay, what we can do instead is we can do this. Pick greeting takes a list of strings, which is going to say sort of the pool of potential greetings to show the user, and it's going to return a command message. What is a command? Okay, so going back to our Elm architecture diagram, just a quick recap of how we've ended up where we are right now. We saw model, view, and update and how they relate to one another. View returns some HTML, such as like an H1 that has the text feed. Potentially those HTML values have handlers on them that respond to user inputs by sending messages through update. Initially, we had our messages being described as records with description and data. And we kind of saw that that didn't really scale very well. So we ended up refactoring it a little bit later to this, where now we have custom types for this and variants that hold on to whatever additional metadata we need about the message that update's going to need to use with the current model to return a new model. Okay, that's where we are right now. Commands essentially introduce something new to this. It gives update a new capability. So previously, all update could do is it would return a new model, and that's it. It would say, give me a message on the current model, and I will give you back the new model to transition to. It's still going to be able to do that in this new world we're about to move to, but it's going to have one additional capability. And it's going to be based around this idea of the message. So message, fundamentally, its job is it's how the Elm runtime talks to update. Up to this point, the only thing it's had to say to update is, here is some user interaction that happened. Like the user clicked a thing. We saw on input in a previous exercise when the user was typing into a thing. Fundamentally, the only thing the Elm runtime has had to say to update is, here is a piece of user interaction that happened. Commands introduce a second thing that the Elm runtime can say to update. So this is something that goes essentially from update and then to the Elm runtime. Then the runtime sends a message to update as a result of what update said to the runtime. So whereas the user interaction case is coming from view says, here's my message that I want the runtime to send to update in response to this user input. Commands come from update. So this is update saying, hey, I want you, the runtime, to go run this command. And when you're done, give me back this message, and I'll continue on from there. So essentially, a command is a description of something that you want done. It's not a side effect in the sense that when you instantiate a command, nothing happens. If you want, you can instantiate 1,000 commands in a row inside update right away, and nothing will happen as a result of any of them. It's basically just a description written down saying, hey, dear runtime, please do this, and then tell me about what happens. Thank you. And when update returns, now it's going to return a tuple of the model, so just like before, it's still going to be returning the new model, as well as, optionally, some commands to run. And so the runtime is going to say, okay, I know what to do with the new model, do the same thing as before, pass it to view, continue that cycle, but also I'm going to look at this command you gave me. And the command's going to tell me possibly to do something. So what we're building up to is we're going to use it for HTTP requests, but in this case, we will also use it for randomness. So random.generate gives us back a command message that says, hey runtime, go randomly produce one of these values, randomly pick from one of these greetings. Yeah, you can choose a different one every time. I don't care. But when you're done, send me a message telling me which one you picked. And so in this way, we sort of isolated that unpredictable, that side effect-y kind of element inside the runtime. It's the runtime's job to do all of that stuff. Update is not concerned with that. Update just says, here's a description of what I want done, and every single time you call update with the same message and model, you are 100% guaranteed to get back the same model as a result, or the same model value as a result, and the same command value as a result. So update itself still obeys this guarantee that Elm has. Same arguments, same results, but we're still able to end up with a randomly selected greeting. So as an example here, we got pick greeting, has a list of strings, it returns a command message. Update can call this function, return that command, and say, hey, runtime, when you're done, give me back like a set greeting 5 message, and I'm going to process that the same way that I would process any message that I got from the view.